we have here is maintenance. In that maintenance, we have different topics like vector, scalar, tensions, among others. Well, here we have vector. What are vector? Vector quantities. These are measurable quantities that has magnitude and direction. And one of the examples of vector is force. So if you look at this question, we have force, and this is the magnitude of the force, this is the direction of the force. 20 newton is the magnitude, 150 is the direction, so it continues. So the question says we should determine the resultant of this force. So let's first of all understand what a resultant is. Resultant force is. A resultant force is a single force whose value is equal to sum of all forces acting at a point. So when we sum all these forces and their direction, to have a single force, that force is called a resultant force. But to do that, we need to understand two basic concepts. One, resolution of forces, and sign convention, including cardinal points. That is 3 points we need to understand. So what is resolution of force? It's a system of resolving a single force into two components, x and y components. Let's assume we have the y component now, while this is the s component. If we have an inclined force, F, inclined at an angle theta to the horizontal, how do we resolve this? So by pushing this force to the vertical axis, and also taking the force to the horizontal axis. To do so, let's create an imaginary line at this point. So what we have now is a right-angled triangle. So if I should simplify this right-angled triangle by looking for the opposite and the adjacent, we have to apply SOHCAHTOA. So opposite hypotenuse, because the hypotenuse is the value of this force. So opposite hypotenuse, that is sine. So here will give us F sine theta. While adjacent hypotenuse, that is cos. Here will give me F cos theta. So where is the point? Anytime I'm resolving this inclined force, I'm pushing it to the vertical axis. So the force move with the angle. But what's the sign ratio? Is sine theta. Anytime resolving into your horizontal axis, by pushing this force to the horizontal axis, what's now the trigonometry ratio? Is cos theta. So this force is now a dummy force. That means it no longer have use after I'm done resolving it. So yes, also F sine theta, because this line and this line are parallel to each other. So this is the concept of resolution of force, resolving a single force into vertical components and horizontal components. Another point we need to understand is cardinal points. The cardinal points is the point that shows the four cardinals of the earth, which is north, south, east, and west. So the east is our reference point 0, the north is 90 degrees, the west 180 degrees, south 270 degrees, then back to 360 degrees. So the angle between the east and north is 0 to 90 degrees. The angle between north and west is 90 to 180 degrees. The angle between west to south is 180 to 270 degrees. Then from south to east is 270 degrees to 360 degrees. So if you go back to the question, they say the 10 Newton force is inclined at 60 degrees. You say it falls under the first quadrant. 20 Newton force is inclined at 150 degrees. That means it falls under the second quadrant. 15 Newton force inclined at 225 degrees. It falls under the third quadrant. And 5 Newton force at 300 degrees. It falls under the fourth quadrant. Then this is another concept. So let's also understand the concept of sign convention. This is sign convention. In sign convention, here is my x and there's my y axis. So and here is my reference point. If the arrow is acting to the right hand side, it's a positive x axis value. If you're acting from the reference point upward, it's positive y value. From the reference point to the left hand side is negative x value. From the reference point down, and the arrow is pointing towards the horizontal axis, positive horizontal axis, that force becomes positive. If I'm resolving the force and the arrow is pointing towards the direction, it's a negative force. With that, let's go back to our questions. All right, so with that explanation done, let's answer the question. So we should find the resultant force. Like we said earlier, it's a single force whose value is equal to the sum of all forces acting at a point. So don't forget, the question says the angles are measured from the horizontal line in anti-clockwise direction. That is to say, they rotate in this form. The angles are rotating in this form. So let's draw, and this is my x. The direction is 60 degrees. That is to say, I'm moving from 0. Don't forget, our quadrant 0 to 90, 60 happen to fall under 0 to 90. So let's rotate it. Let's take it from here as our 60. Here I have 10 Newton, 60 degrees. The second force is 20 Newton, and the direction is 150. So let's look for 150. Here's my 0. If I trace from here to here, according to the cardinal point, here is 90. So here is now 90. I'm looking for 150. Let's assume some here are 150. Here I have the second force of 20 Newton. The third is 15 Newton as 225. Let's trace 225. Here's my 0, 90, 180. Let's assume here is our 225. I have a force of 15 Newton. And lastly, 5 Newton at 300 degree direction. So let's trace that. Here is 0, 90, 180, 270. Let's assume here is our 300. Here I have a force of 5 Newton. So if you clearly look at the diagram, it's a little bit rough. So, but our interest here is the force and the angle inclined to the horizontal axis. That force and the angle to the horizontal. So if I should go by that, for the force of 20 Newton, the direction is 150. So what is the angle to the horizontal? This horizontal axis now, from here to here is 150. Here will give us 30, because from here, from 0 to this point is 180. For the third force of 15 Newton, direction is 225. So to the horizontal, I will have 45 degrees. And lastly, for the fourth force of 5 Newton, the direction is 300 degrees. So what is the angle to the horizontal? Is 60 degrees. So let me draw the diagram using the force and only the angle inclined to the horizontal axis. With the angles inclined only to the y and x. The first one is 10 Newton, 60 degrees. The second is 20 Newton, 30 degrees. The third is 15 Newton, 45 degrees. The angle to the horizontal is also 60 degrees. So now we have it as such, we can now resolve the force by applying the concept of resolution of forces. We take a single force to the vertical and a single force to the horizontal. So we are going to do it for each and every one of them. That will give us the sum of all vertical forces and the sum of all horizontal forces. All vertical forces now summation f of y. So if I should resolve this force to the vertical axis, as we know it, is the force and the sine angle, and it's a positive force according to sine convention. It's positive. So that will give us 10 sine 60 degrees. If I should resolve the second also to the vertical axis, it's also positive. The arrow is pointing upward. I will have plus 20 sine 30 degrees. If I should resolve the third to the vertical axis, you can see it's pointing downward. According to sine convention, is negative. I will have minus 15 sine 45 degrees. If I resolve the fourth to the vertical axis, you can see the arrow is pointing downward. According to sine convention, it's also negative. I will have minus 5 sine 60 degrees. So calculator will do the remaining job. 10 sine 60 will give us 8.660. 20 sine 30 is 10. 15, 10.606. 5 sine 4.330. So if I should add up, I will have 24.3 2.94 Newton. So let's also resolve all the forces to the horizontal. That will give me the sum of all forces acting horizontally. So if I should reverse the first force, you can see it's pointing towards the positive x direction. That means this force is positive. Cos 60 degrees. It's pointing towards the negative x direction according to sign convention. That will give me minus 20 cos 30 degrees. If I resolve the third, so also taking us to the negative x direction, I will have minus 15 cos 45. If we do the same thing for the last, resolve this force to the positive x direction, it give me plus 5 cos 60 degrees. So if I simplify what I have with calculator, here will give me 5 minus 20 cos 30 is 17.32. 15 cos 45 is 10.606 plus 5 cos 60 is 2.5. If I add up summation f of x will give us 5 minus 17.32, that will give us minus 20.426 Newton. So at the end of the day, we are having the sum of all forces acting vertically is positive. The sum of all forces acting horizontally is negative. That means the y is going this direction because it's a positive value according to sign convention. See, sum of the force acting horizontally is negative. That means it's acting towards this direction. So with that, we can now draw our net force diagram. Our net force diagram. So the y is positive according to sign convention, plus, plus, minus, minus. The y is positive and the x is negative. So my diagram will go like this. Y is positive, x is negative. So here's my x, and here's my y. So the resultant force, according to the parallelogram law of vector, resultant force will come from the point of concurrency of the two force systems. Here's now my resultant force, R. The reason why we are having the diagram as this, our summation f of y is positive, sign convention, here is positive, negative, sorry, positive, positive, negative, negative. So the y is positive, our f of x is negative, so it's moving in this direction. So our net force diagram will be in this form. So my y is 24.94 Newton, my x is 20.246 Newton. So to find the resultant force, I can create this parallel line here. So here is also 24.94 Newton. There's an angle now between the horizontal and the resultant. Let's call that angle theta. So the direction of that resultant force is now from here to here, which is our reference point 0. It's from 0 to get the resultant force ends. So these two angles are supplementary. That means sum of angle in a straight line. Here will give me 180 minus theta. So with that, I can determine the resultant force by applying Pythagoras theorem. It says that the square of the hypotenuse, the square of the adjacent, which is our summation f of x, and the square of the opposite, summation f of y. So if I fix in my value, r square will give me 20.246 squared plus 24.94 squared. So if I simplify with calculator, I will have 20.246, 409.90 plus 20, that will give us 622.0. If I add up, 1031.90. Therefore, the resultant force now is now root 1031.90. Resultant force will give us 32.12 Newton. So that's the resultant force for all the forces and the directions given. So let's also determine the direction of the force. To do so, this is the direction of the resultant force from here to here. To do so, I need to get the value of theta. To get theta, I need to apply SOHCAHTOA, which is opposite and adjacent. Opposite adjacent, according to SOHCAHTOA, is tan theta. Direction of the force. Direction of the resultant force, which is arrow. So we're having tan theta as opposite over adjacent. Who is the opposite now? Is our vertical force, which is 24.94. I'm having 24.94. The adjacent is the horizontal forces, 20.246. So tan theta will give me, that will give us 1.232. So theta alone is now the tan inverse of 1.232. Theta will give us 50.9 degrees, which is approximately 51 degrees. Therefore, the direction is now 180 minus 51, which is 180 minus 51, 29 degrees. So this is how to apply the concept of resolution of forces, cardinal point, sign convention in solving or determining the resultant of a force if multiple forces and angles are given to us. Our interest is to get each force and the angles inclined to the horizontal. So thank you for watching. I hope to see you next.